Hello, I'm Maurieos. Here we are with the third of the questions from tutorial 5, this one with a mechanical flavour. Poor old Bob here is at the bottom of the conveyor there, sorting out a few things, and there's rocks going up the conveyor. Now, the regulations say, or the standards or whatever for the conveyor, that it must be at an angle of no more than 20 degrees to stop rocks falling back down on it and giving Bob all sorts of scares and things like that. So we've got some measurements on the conveyor, the horizontal distance from head roller to head roller or roller to roller, and the difference in height from the centres of the rollers. So it remains to work out, well, whether that angle, whether the conveyor, what is its angle to the horizontal. So, well, let's get cracking. And first of all, we'll better sort out the triangle. So there we are, we have this triangle here, nice right angle triangle, and we better label the angles. So we'll call that one A, B and C. Now from there, of course, that determines the names of the sides. It always helps, to label and draw a diagram. In that time while we're labeling and drawing, we can be thinking about our approach and how we might go about doing the calculation and that sort of thing. So it's a good amount of time. So opposite angle A is side A, 6.3. Opposite angle B is side B, and opposite angle C, side C. Right, so we can look at those. We can see where the right angle is. We can see that A will be the smallest angle, B will be the middle angle, or the next one, and then C, of course, is the right angle with the hypotenuse opposite it. And so we'll label that. Well, that's C's the hypotenuse. Now, in terms of angle A, which is the one that we need to determine the incline, or toward, how far above the horizontal the conveyor is, that would be the A is the angle to work out, and that's the one that has to be no more than 20 degrees. And then, of course, we've got the opposite, which is the opposite angle A. So that's got it all pretty well labelled up. And so from there, we go to our mathematical toolbox and pull out our old friend, Sohcahtoa. Here it is. Now, a bit different to the last one, we've got no angles shown. So S, C and T, sine, cos and tan, we don't know what they are. We can't work them out. We don't know what they are. We know what the opposite is. We know the opposite, and we know the adjacent. So if we look at the sine ratio, we can't use that. We've only got one thing. We look at the cosine, nah. We look at the tangent, and of course we've got the opposite and the adjacent. So we've got two, and we can work out the third. So it's the tan that we'll be using. And tan of A equals opposite over adjacent. Filling that in, tan of A equals 6.3 from the diagram over 106.8. And A equals inverse tan to the negative 1, 6.3 over 106.8. Okay, let's see what we can do with that. So we'll get our calculator out and put that up there. Alrighty. So, that should be right. Okay, so we click here Let's all clear. Shift tan for inverse tan, and then we click this little fraction button here in the top one, 6.3. We can put the O, but we don't need to. Drop down to the bottom one, 106.80. Back up, close the bracket. Oh, that didn't close the bracket. Close the bracket, tan to the -1. Oh, that's what we want to find out. Push the equals button, and we get 3.3758. Like so. So we've got to bring our thing back again. There we go. 3.37589. Now that's degrees. That's degrees. 3.4 degrees. I like to show my degrees to 4 decimal places, in case I want to use them later on. Just to that's where I reckon it retains the accuracy, or that's been my experience. 4 decimal places. It can vary, but I like 4. Okay, then we can just go to this button here, if we so desire, and push that button, and that gives it to us in degrees, minutes and seconds, which, as an old surveyor, of course, that's what I like. 3 degrees, 22 minutes, 33 seconds. So, yes, the conveyor complies. Does it? And that was the question. It's less than 20 degrees. Yes, it's less than 20 degrees, so it complies. Now, questions like this, sometimes this one is perhaps not particularly well worded, because really you could have just said yes or no, and then you'd have a 50% chance of getting the answer right. But usually you'll need to show working, so it'll say prove the conveyor complies, or show that the conveyor complies, rather than does. So you might see a more different form of the question, where it's important that you do the working. But anyway, poor old Bob's safe. No rocks will fall on his head, according to this standard. Bloody marvellous.